Hey, what's up, Logic fans? Welcome to our second video on 4.9. This is video 4.9b. Let's continue an example here. Okay, so picking up where we left off last time. So I'm imagining a domain that's got three objects in it, A, B, and C. All right, and we suppose that each of these represents a person in a race. Okay, and that in that race, A beat B and B beat C. Okay, so that's what's going on in our domain. Now, fxy is the faster than relation where this thing is faster than this thing. So my first question for you is picking up right where we left off at the end of the last video. Can you find all logically possible sentences with respect to this relation and this domain? Pause now. Okay, well, hopefully you're able to figure it out, but right, how many are there going to be? Well, there's going to be 9, right? Why? Because it's going to be 3 squared. All right, so the sentences that we're going to be able to form are as follows. Right here, okay? So these are all 9 possible sentences you could form. You have A is faster than A is faster than B, A is faster than C. These are all the 9 possible sentences you could form with respect to this relation and this domain, okay? So now the question is on this particular domain, right, are these sentences true or false? Okay, right? So these are separate things here. What are the possible sentences, and then what are their truth value on a particular domain? So go ahead now and pause and see if you can figure out on this domain whether these sentences are true or false, and that's going to convince you that you understand the meaning of the expression, okay? Okay, so let's go through it together. Well, let's just say for the sake of argument that nothing is faster than itself. So all of these are going to be false. This one, and this one. Okay, everything is as fast as itself is, right? So nothing is faster than itself. All 3 of these sentences are false. Now, on this domain, is A faster than B? Yes, because A beat B, right? So that's true, okay? Now, did A beat C? Well, you have to make a little bit of an inference here, and this is something we're going to discuss later, all right? But A beat B in the race and B beat C. Therefore, A beat C, because faster than is a transitive relation, okay? So this sentence is going to be true based on a really quick deduction. We will talk more about that feature of relations later. Now, here's a sentence. It says B is faster than A. On this domain, is that true? No, it's false on that domain. This sentence says B is faster than C. Is that true? Yes, that's true on this domain, right? Is C faster than A? No, not on this domain. Is C faster than B? No, not on this domain. So this would be how you fill it out, okay? All right, let's keep looking at these so that you really feel like you understand the meaning of relational sentences. Okay, so what we want to do here is start ramping up in complexity and looking at more complex sentences involving relations and make sure we can understand what these sentences actually mean. So here's a domain, this whole thing, both of these things together, all right? So what this is indicating, as is our practice, is that A does in fact have the property F, but A lacks the property G and lacks the property H and has the property J. Similarly, what these guys here indicate is that A bears the relation R to itself. So that's true that A bears the relation R to itself. But this indicates that A does not bear the relation R to B. So you don't actually know what F, G, H, and J are, but you do know, and you don't know what the relation is, but you do know whether these particular sentences are RCC, RBC, not all logically possible ones, but these particular ones, you know whether they're true or false, okay? So the question is from that, can you determine the truth value of these sentences? Start with A. Okay, so we see here that B does not bear the relation R to C, and so this says that that's the case, that B does not bear the relation R to C. It's not the case that B bears R to C. Therefore, this sentence is true, okay? So this is a true sentence. Now, let's keep building here. So what about this one? Is this true or false on this domain? Okay, well, JB is false, so we know that this part here is false, so we're looking at false or not RCC. Well, RCC is true, so this is going to be false as well. right? So you have false or false, which results in a false statement, all right? So this is working the exact same way as everything before. Now, in the case of C here, what we have is a conditional, right? If you were to build this sentence from scratch following our quantificational sentence rules, a la 4.8, okay, you would use this last and therefore see that this sentence is a conditional. Its antecedent, FA, is true. So we've got to check the consequent, RAB, which is false. So this is true arrow false, which of course is false, all right? Now, let's try this one, JC, if and only if not RAA. RAA turns out to be true, so not RAA turns out to be false. JC turns out to be false, so this is a false tribar false, which results in a true. Okay? So that sentence was true. Let's keep going here. RAA and not RBC. RAA is true. Not RBC is going to also be true. And not RAB is also going to be true. So this is true arrow true ultimately, which ultimately evaluates to true. Okay, GB, well, this part here is going to turn out to be false. RCB we do not have, okay? That is not on here. So we have no idea what this is, and so the ultimate truth value here is undetermined from our domain, okay? That's the point there. Now, RCB, what's that? RCB, we also do not know the truth value of that, okay? So we're going to have question marks here, but HB, do we know anything about that? Well, we know that HB is true. Here's the key thing. We also know from the truth table from OR that if you have a true consequent, that the conditional is true. So even though you don't know this one, you can still determine that that sentence is true, okay? So those are the kinds of little tricks you have to look for, and hopefully this is helping you understand how you're supposed to be reading and looking at and understanding relations. Okay, now that you've got that base under you, and you can kind of read off, you know, what an expression, like for example, like you know, this one means, okay, and understand it, and you know you can look at it from one of two perspectives equally. The idea here is let's start looking at sentences with relations that involve the quantifiers and see if we can start unpacking what those sentences actually mean, okay? So let's try to understand what those sentences mean. So once again, we're going to let LXY be the loving relation, X loves Y. We're going to let A be Ash. Little a stands for the guy Ash. So the question is what does this sentence mean in ordinary English? Pause now. Okay, let's work on this together. What this sentence means is pick anything you like out of Santa's bag, anything in your domain bag. Anything you pick out of there is guaranteed to satisfy this description. It loves Ash, right? In other words, everything in my bag loves Ash. All right, so that would be the translation of this first one. Everything loves Ash. Let's contrast that really quickly with B. Take a stab at B. What does B mean? Okay, B means that everything in my bag satisfies this description. Ash is loving it, right? Everything in my bag is loved by Ash. So we could say Ash loves everything. Okay, that would be from the perspective of this right here. From the perspective of this, you would say everything is loved by Ash. Ash loves everything. Everything is loved by Ash. Those would be fine translations of this particular sentence, okay? So notice the important role that the position of X is playing in A and B respectively. Everything loves Ash and Ash loves everything mean very different things. On some domains, both of these are true. On some domains, both of these are false. And on some domains, one of these is true and the other is false. They mean different things, okay? All right, let's go ahead and try C here. What does C stand for in ordinary English? Okay, so hopefully you're pausing and trying these out, but, you know, with the existential quantifier now, this says at least one thing in my domain, there's something in there. Reach around, at least one thing in there satisfies this description. It loves Ash. So we could translate that, something loves Ash. At least one thing loves Ash. There's at least one thing in my domain that loves Ash. Okay, here's this one. Try this one. Okay, this one says at least one thing in my domain is loved by Ash, or alternatively, Ash loves something. Ash loves at least one thing in my domain. Now, I want to be really, really careful about something here, okay? Ash loves at least one thing, all right? Ash loves at least one thing. This one we just did here, Ash loves something. That could be Ash himself. Ash loves at least one thing in the domain, including possibly himself. So suppose you've got a domain and it's got three things in it, Mickey, Minnie, and Pluto, okay? And let's just suppose that none of them can stand each other and none of them can stand themselves, but let's suppose Mickey loves Mickey and every other possible relationship there. Okay, so there'd be 9 possible loving sentences. They're all false except Mickey loves Mickey, right? In that situation, this is true. So there is at least one thing that Mickey loves, even though it's himself, if there's at least one thing that he loves, okay? So that includes that. And by the way, when this says everything loves Ash, that includes Ash. Everything in my domain, which includes Ash, right, loves Ash. So Ash loves himself too is a logical consequence of this. Similarly here, this is a situation where Ash loves everything, and that's going to include Ash loving himself. So I'm not sure if I stated this one correctly, but everything loves Ash. That's going to include Ash loving Ash. And this says Ash loves everything, which is also going to include him loving himself, okay? All right, so I wanted to make that point that these things include the thing possibly loving itself, okay? All right, let's keep looking at some examples here. Let's try one that's a little bit different. Let's try this one. Let's try, let's do this. Let's do for all x, LXX, okay? What's this say in ordinary English? Pause now. Okay, this says everything loves itself. Okay, so if I have 3 objects in my domain, A, B, and C, this says that no matter which thing I pick out, A, B, or C, it satisfies this description. So A loves itself, LAA, and B loves itself, LBB, and C loves itself, LCC. Okay, and no more. Maybe they love each other, maybe they don't love each other, but this is just guaranteeing that it loves itself. Okay, and if we were to do it with the existential quantifier, let's go ahead and try that case right now. Right, at least one thing loves itself. All right. So this, switch this to F really quickly, right? This is just going to say that something, at least one thing, loves itself. All right? That's exactly what that means. All right, so there's at least one thing in my bag, one thing in my domain bag. I reach in there, I reach around. Might only be one thing, it might be 10 trillion things, okay? But there's at least one thing in there that satisfies this description. It loves itself, okay? Okay, let's spill on to the next video where we're going to keep ramping up in complexity, looking at sentences involving relations and understanding what they mean. So let's look for video, what would it be, 4.9C. See you there.